In the previous reports, we have learned all the concepts regarding weather and its factors affecting, like temperature, atmospheric pressure, fronts, wind speed, humidity, and many others. We had also discussed about weather forecasting and its steps before finalizing the status of weather. At this moment, the fourth group were tasked to tackle about weather charts and graphs and how are these significant in weather patterns and tracing. And finally, the group will also discuss the types of weather maps and the thunderstorm phenomenon. So be prepared and enjoy the rest of the discussion.
Good morning, ma'am. Good morning, classmates. I am Joy A. Manzo, and I am going to discuss the different types of weather maps. So, let's start. But before we dig deeper the different types of weather maps, let us first define what is a weather map. So, weather map is used to show weather facts about specific place at a given time. It can show temperature, cloud coverage, rain or snow, wind, air pressure, humidity, and the direction a weather system is moving or expected to move. Weather maps can use isotherms, and if we talk about isotherms, it is a line connecting locations with like temperatures. So a weather map is also known as synoptic weather charts, simply because it displays various meteorological features across a particular point in time. A weather map shows different weather indications to tell about prevailing weather conditions in an area. And a weather map has 5 types, which are the pressure maps, the aviation maps, the temperature maps, the station model maps, and the streamline maps. So with the different types of weather maps, it tells a different weather story with each one. Some may show the atmospheric pressure or the temperature. Some also show multiple types of data in order to give a well-rounded indication of the weather conditions in a particular area. So, in my part, I am only going to discuss the 2 types of weather maps, which are the pressure maps and the aviation maps. So, what is a pressure map? Pressured maps are measured in millibars and tell the readers where there is high atmospheric pressure as compared to average sea level pressure and where there is low atmospheric pressure. So in general, high pressure areas means that the air is very stable and usually denotes good weather conditions. Low pressure, on the other hand, means that the air is less stable, clouds can form, and rain or storms can ensue. So according to weather questions, low and high air pressure systems are caused by the heating and cooling of air masses. So they vary daily. So how do you know if a map has low pressure? Atmospheric pressure is measured with an instrument on the ground called a barometer. On weather maps, these readings are represented as a blue or a capital letter H for high pressure or a red for low pressure and has a capital letter L, and that is a pressure map. How about the aviation maps? So aviation maps are live weather maps specifically containing information necessary for the safe flight or aircrafts. Information such as wind speed and the direction, dew point readings, flight advisory information, temporary flight restrictions, cool and warm weather fronts, and icy areas are all displayed on aviation maps. So this information is updated in real time. Why? Because so that the pilots have an exact map of weather conditions and flight conditions and can safely navigate the skies. In addition to, these aviation maps can also be an aeronautical chart that all sorts of maps used for air navigation, provided that they include at least some of the following information. For example, the topographic features, the hazards and obstructions, navigation routes and aids, the airspace, and the airports. And that is the aviation maps. So, to sum up everything, if you talk about pressure maps, it talks about the high pressure and the low pressure. And a high pressure is when the air is stable and usually denotes a good weather conditions, while low pressure systems usually has less stable. The air is less stable and usually there is rainy or stormy weather. So we can see that, or we can read the weather pressure maps. If it is high pressure, it is blue, and low pressure, it is red. So in aviation maps, it is necessary for the safe flights and aircrafts. It is updated in real time so that pilots have an exact map of weather conditions and can navigate also the skies. And it is very important to know the differences between the pressure maps and the aviation maps. So that's all, and I hope you have learned something from me and you have learned something about my topic, the pressure maps and the aviation maps. That's all. Thank you.
Okay, students, in this screencast I want to show you how to complete the graphs for the Weather Watch. The first graph that I'm going to ask you to create is the temperature graph, and so what I want to do is I want to select column A, holding down Control, select column B, C, and D. So the temperature, the high temperature, and the low temperature. Now I'm going to come up to the Insert ribbon, choose the Scatter. Sometimes this first one up here with lines on it gets a little glitchy, so I'm going to suggest you use the straight line with the data points on it, so this chart type here. I click that, instantly the graph is made, but it's tremendously small and very difficult to read. So I'm going to come over here and right click on the field of the graph and ask the computer to move the chart to a new sheet. Right away I'm going to label this as the temperature graph, that way I can find it more easily. Click OK, and now the graph is much easier to read. I want to adjust the layout, so I'm going to come up here to the chart layouts and choose layout 1. This allows me to give a title and the axes to be titled. Right away as I look at this graph, I see I have a terrible error here. There's no way that the temperature at noon would fall outside the lowest temperature for the day. So I can hover over this data point and see that it was on 1010. Come back over here to my data sheet, find 1010, and I typed in 26. What I know happened this day is it actually was 62 degrees. As soon as I hit enter, I come back over here to my graph and the graph is automatically corrected. Now, with the title, I need to title the graph. In this case, it is the 2017 Weather Watch at noon. So I'm going to ask you to include the time of when you did your observations, and then we want to title the y-axis, in this case, and that was recorded in degrees Fahrenheit, and the x-axis is the date. Now, you may want to adjust a few things. One of the things, since we'll be reading this graph later, I'm going to right-click over here on the axis, and sometimes you have to be really careful about exactly where you click. But I'm going to add some grid lines. That way I can read the numbers more easily. I'm also going to come over here and add some grid lines for the date. Now it looks a little more like a traditional graph. One of the other things I might suggest you do is you can come over here to the design and layout. You may want to choose different designs or layouts. If you like a different color background, that's very easy to do. The one thing I will caution you is beware of choosing some of these selections where it's difficult to tell the difference between your data sets. So one where you use different colors is very helpful. Now, it is possible to choose your own colors, and I'm sure some of you can figure out how to change the color of your data points and your lines. One of the other things that you might also want to do is if you format the axis for the dates, one of the choices you have is adjusting the alignment, and the text direction here shows to be horizontal. If I change the text to rotating it 270 degrees vertical, now I can see that and read the dates a little more easily. I may want to adjust my graph though so that it is actually smaller, and if I click on just the right spot here we go. Now I can make it smaller. My dates show up nicely on my chart. So again, I want your weather watch, the time up here, in this case was noon, your name, you should have your different temperature lines labeled, your axes labeled, and the dates clearly showing. So that's the first temperature graph. Now the second graph I'm going to ask you to make is the temperature along with the date and the dew point. So again, I click on each column holding down Control while I click the column. I'm going to come back here to my insert ribbon. Once again, choose a scatter graph, choosing the straight lines with dots. I need to move this to a new sheet. In this case, I'm going to call it temp and dew point, and move that to the new sheet. Click OK. Again, choose a better layout. So this is the 2017 Weather Watch, and this is temp. I misspelled that. At noon, and your name. Now the axis over here is temperature, and the axis here is date. Again, I think it would be a really good idea if you added some grid lines, so I'm going to add some lines in here, click here, add some grid lines. Again, if you choose to rotate the dates under the format axis, you can come in here under the alignment tab, change it from horizontal to vertical, and that will allow you to have your dates much more easily read. So now I've got my temperature and dew point together on one graph. Again, name, title, each axis labeled, and correct data. Double check your data here. Make sure your temperature line never drops below the dew point. If your temperature line drops below the dew point, you know you've mistyped a number. Now I'm going to come back to my data sheet one final time to make the last graph. In this case, I want to do the barometric pressure graph. So select the date column, holding down Control, I'm going to come over to this column and select pressure. Now back up to the insert ribbon, choose a scatter graph, a straight line with data points, and oh my goodness, I clearly see right away that I have an error. I'm going to go ahead and move this chart to a new sheet so I can see what's going on. I have pressure. Click OK. I have some bad data in here on 1010 again. Must have been tired when I was typing those numbers. I come over to the sheet on 1010. Right here, 118. I'm quite confident that the pressure was 1,018 because there's never been a pressure that low for a weather station in Greensboro. So again, if I hit 1,018, come back here to my pressure graph, it looks much more reasonable. Again, I'm going to come over here to my Design and Layout tab, choose the Layout 1 so I can label my graph. Again, I want to have the label up here as 2017 Weather Watch, and this was at barometric pressure at noon. And put my name up at the top as well. Now I label the axis. This is barometric pressure in millibars. And dates down here. Again, let's format this axis, add some grid lines. I'm going to adjust the alignment to make the dates a little more easily read. If I slide this up, my dates all show up. I'm going to go ahead and add some minor grid lines in here and have a completed graph. You'll use these graphs to answer the questions. Again, double check each graph correctly has the year and weather watch, the time that you did your measurements, and each axis should be clearly labeled for all of your graphs. Each of the graphs, again, if you'd like to format it with a special background, you can even put pictures and things like that behind it. Make sure any extra graphics you put on are not confusing and cluttering up the graph too much. And you'll turn these all into the class Dropbox.
How to read a weather chart. From a geography lesson at school to a weather forecast on TV, most of us have seen a weather chart. Weather charts are very useful tools for weather forecasters to get an overview of the weather. They may look complicated with lots of information, but actually they aren't too hard to understand. Weather fronts, cold front, a line behind which colder air lies, with the way triangles point showing the direction of the travel. Warm front, a line behind which warmer air lies, with the way semicircles point showing the direction of travel. Occluded front, a line behind which cooler air lies, with the way semicircles and triangles point showing the direction of travel. Trough line, an area of enhanced activity often causing showers. Air pressure, continuous lines are isobars and join up places with equal air pressure. L stands for low pressure and H for high pressure. Numbers at the center of high and low pressure systems mark the central pressure. Numbers on solid lines mark the air pressure along that particular isobar. Temperature of the air. Dotted lines with numbers on the mark of thickness of the lowest 5 km of the atmosphere. A higher thickness and number equates to warmer air. A lower thickness and number equates to colder air. Thickness numbers. 492 is equal to extreme cold. 510 is equal to very cold. 528 is equal to cold. 546 is equal to mild. 564 is equal to hot. 582 is equal to extreme heat. you want to see what the weather is going to be for the next few days, you turn on the TV and watch your weather person talking about what weather to expect. A map is shown with a bunch of H's and L's of lines on it. What does all this mean? Well, the H's represents an area of higher air pressure. Higher air pressure is generally associated with fair or good weather. Air is moving in a clockwise fashion away from a high pressure. The L's represent an area of a low pressure. Lower air pressure is generally associated with cloudy or stormy weather. Air is moving in a counterclockwise fashion towards low pressure. The blue lines with a point to show the leading edge to the colder air, so it is known as a cold front. Points show the direction the cold air is moving. The red lines with the rounded symbols are the leading edge of a warmer air, and it is known as a warm front. Like the cold front, the rounded edges show the direction of air movements. A line having alternating cold and warm front symbols is a stationary front. This means there are two different air masses like to each other, but neither one is moving. A propaline with the cold and warm front symbols on the same side, cold and occluded front. When this is present, it means the low pressure system is beginning to fade away. From these few basics, look at the map of weather conditions. You can predict what direction the wind is coming from a different map. What kind of weather is occurring based on H and L pressure positions in the map.
Good day, mates. I am Marianita Mundihar and I will be reporting about how to read weather maps. So, weather maps are also known as the synoptic chart, are an example of an isoline map. Isoline maps are made up of lines that join points of equal value. Contour lines drawn on a topographic map are another example of an isoline map. Weather maps use lines called isobars, plus other symbols to join together lines of equal air pressure. Today, most meteorologists use the hectopascal for measuring atmospheric pressure. Many weather reports the public use of millibar. 1 hectopascal equals 1 millibar on the American weather maps. The isobars are drawn at intervals of 4 millibars. 1013 millibars is the average sea level air pressure. Therefore, areas with an air pressure of over 1013 millibars are considered to be areas of high pressure, and the areas with an air pressure below 1013 millibars are considered to be areas of low pressure. On a weather map, areas of high pressure anticyclones are identified by letter H. These areas are associated with clear skies and little wind. Areas of low pressure or depressions are usually identified by the letter L and are associated with rain, clouds, and high winds. High pressure systems have enclosed isobars which increase in pressure towards their center. Low pressure systems, on the other hand, contain isobars which decrease in pressure towards the center. When isobars make a sharp bend around the low, this bend area is called a trough. One of the main symbols employed in a weather map is called the front. A front represents the boundary between two air masses and appears on a weather map as a line with triangles or semicircles attached. At the front of two masses, there is a stormy weather. There are 4 types of front most commonly seen on weather maps. A cold front is the boundary where a cold air mass pushes underneath the warm air mass, forcing the warm air mass upwards, which forms clouds and rain. A cold front is represented by a blue line with the triangles pointing towards the direction of movement. A warm front is the boundary where a moving warm air mass is replacing a cold air mass. Warm front is represented as a red line with semicircles pointing towards the direction of movement. Warm front moves more slowly than cold fronts because it is harder for warm air to push against the denser cold air. As the warm air rises above the cold air, water vapor condenses, forming high clouds. Light precipitation can fall in areas as the warm front passes. A stationary front is the boundary between two air masses which are not moving. Neither mass is strong enough to move the other, therefore a stationary front can be pushing back and forth over a given area for days. A stationary front is represented as an alternating warm and cold front symbols. An occluded front is a composite of two frontal systems that merge as a result of occlusion. Cold fronts generally move faster than warm fronts. Therefore, the cold front will overtake a warm front and force it aloft. An occluded front is represented as a purple line with triangles and semicircles. Weather maps also show wind conditions. Wind is the movement of air. Wind moves from high pressure areas towards low pressure areas. Winds do not travel in a straight line due to the Coriolis effect. This effect is created by the rotation of the Earth. The Coriolis effect deflects wind to the left in the southern hemisphere and to the right in the northern hemisphere. Thus, in the southern hemisphere, wind flows clockwise around low pressure systems and anti-clockwise in high pressure systems. In the northern hemisphere, wind flows anti-clockwise around low pressure systems and clockwise around high pressure systems. Generally, wind flows towards the center of low pressure system and away from high pressure systems. When isobars are close together, wind is strong. When isobars are far apart, wind is weak. Now, it's time for you to see a weather map and see if you can interpret them.
So, maayong udto kaninyong tanan. Good morning, Good afternoon, Miss Pedri. Good morning, B2. I am Christian Lloyd Engoho. And ang pasensya kay murag hinay ang tingog ron kay giubo ko da. And then murag na ko'y bisita. Si Whitey. So today, this afternoon, we will be tackling about thunderstorms. So, how do thunderstorms form, or what are the requirements in order for a single thunderstorm or a multiple thunderstorm form? So we're gonna start our slide. Our picture. So basically, thunderstorms, these are rain showers accompanied by lightning and thunder. So with the mixture of flashes of light plus rumbles of thunder. So thunderstorms are small, intense weather systems that make strong winds, heavy rain, lightning, and thunder. So nakuha na-acquire naman na to pag mga last topics na ang mga places na naay occurrence of thunderstorms are with low pressure areas, or ang mga hangin is or ang air movement is moving in towards in one direction. So mana siya. So thunderstorms can happen everywhere with two conditions. So actually na ay 1,800, more or less 1,800 thunderstorms na mahitabo worldwide. Worldwide pa na. And then, so unsa yung mga requirements ani thunderstorm nganong naay ingon ani na mga phenomena. Unsa may importansya ani? So there are two conditions or two requirements. The air near the Earth's surface must be warm and moist with lots of liquid. So ang kanang warm air nag-carry na siya kanang moisture or kanang mga water vapor, then musaka na siya, and then explain na nako na later ang mechanism sa the formation of thunderstorms. So, and the atmosphere must be unstable. 100 lightning bolts hit the earth every second, and at any one moment, about 1,800 thunderstorms happen around the earth. So, muna akong gisulti ganiha, 1,800 thunderstorms, and it could be with different types. Next is wind and rain somewhere. So, at any given moment around the world, hundreds of thunderstorms are occurring. Many of them feature nothing more than a moderate breeze, heavy rain for a short while, and some lightning and thunder. So dili jud ni siya mawala. Na jud ni siya mahitabo sa every naay thunderstorm nga moabot sa usa ka place. And then occasionally, however, these storms seem to run amok and became violent. So maabot siya sa punto nga mugrabe siya, magka-intense siya, na maabot na sa extent nga naanay mga casualties, danay mga lives na igo sa lightning baron, and then Mato sa una pagkabata naka-relate ko nga naka-relate masad mo nga every time like thunderstorm, lightning, grab tago jud na like ibali ang samin, and then ang mga dapat di ka mogamit og cellphone kay mao kuno makakandak daw kuno makadakop sa ngipon sa kilat. So dapat jud ta motuos ko mga beliefs. Pero not usually. So dropping heavy rains which causes flooding can cause flood. Heavy kanang grabe jud kaayo ang pagbunok sa uwan, like it can samot na sa mga downtown areas like sa kanang Cebu City, like grabe jud kayo ang baha kay places with low altitude kanang sa mga low areas, mga low lying areas is dali ra na sila makuanan sa tubig. Samot kanang silingan ra sa dagat ug sa kanal ang Cebu City. So producing half that damages crops and property. So of course maigo ang agriculture and ma-affect ang supply sa mga commodities, and spawning tornadoes and surface which more than 160 kilometer per hour. So thunderstorms can also cause tornadoes, wind tornadoes at sa mga range mga 100 to 200 kilometer per hours, which can be very perilous o grabe makamatay kumada ka or inyong balay. Okay ra balay masud kaysa sa inyong kinabuhi, importante man dyan na. Next is convection currents. So ang convection currents is relate na siya somewhat like dili ra kayo ni siya i-talk more i-dugang pa ni nako or i-talk explain deeply, but convection currents are somewhat like kanang nagpakita ra nga these are the kanang principles na follow or forma ang usa ka thunderstorm. So what are convection currents? Convection refers to the vertical transport of physical properties of a substance due to instability. So we all know that convection is the transfer of heat from via transport of a medium. Sample sa mga conductors like kanang ang kutsara dali siya sahib dito conduction dito day. So a good example of convection is the rising bubbles in a pot of boiling water. So mani siya ang image. Mani siya example of convection. Ang warm water nga nasa bottom murise siya, and then ang cool water nga nasa top sa layer sa water is mo sink in siya para mo replace siya, then mo replace siya sa what do you call this sa position sa hot water. So mag-cycle na siya, and then fluids with different temperature is dali ra maka transfer of heat. So manay mahitabo sa atong sa formation of so another example is a cumulus fair weather cloud. Cumulus clouds are the puffy white clouds and resemble cotton balls. So actually ang clouds, ang analogy ani is ang kanang steam nga nagawas bitaw sa pot is mo na siya ang clouds. Mo na siya ang result sa warm air nga nisaka, and then it kanang releases steam. Mo na siya visible na nato siya makita. So mga siya ma-compare or ma-compare na siya nato sa analogy sa clouds. So siya gamit sa clouds. So rising warm air mass. Sorry, gibinhod ko. Sorry. Rising warm air mass. As the warm air rises through the unstable environment, the air begins to cool. So needed jud nga mo rise ang warm air mo rise para mukul ang surface sa earth. So in connection to that it's kanang warm air rises and then water vapor is mo ubansad but up sa atmosphere. So when the air has cooled sufficiently and the relative humidity reaches close to 100%, the moisture in the bubble begins to condense. So when condensation occurs, gaseous water vapor is converted to liquid water droplets, and the droplets and bubble became visible. This visible water that has condensed is what we see as cloud. So mga to siya, ang warm air nga naa sa lowest layers of the atmosphere is Muraisia, and then causing the they call this the fluids or the water substances nga nasa earth mo turn into water vapor and mo carry og moisture, and then Muraisia dito sa troposphere specifically, and then mo build up na siya, mo condense mo condense siya, and then it will form little droplets, mga little pa na droplets, and forma din siya mga little white puffy clouds, and then dito ra siya ma-condense. Then actually mo grow ang kanang cumulus cloud into 10 miles. Na siya kataas, din na siya anvil top. Ma-explain na ako later. So mga to siya, warm air rises, and then mo condense, mo form og clouds. Gets na ninyo? So the visible water that has condensed is what we see as clouds. So mga to mga clouds na makita mo na ang mga transported na mga water vapor nagikan sa Earth's surface. Next is the recipe of a thunderstorm. So kung naay recipe or ingredient sa luto-luto, ako ganahan jud kog luto, pero napoy recipe sa thunderstorm. So unsa ni sila? All thunderstorms require 3 ingredients for their formation. First is moisture. There must be an abundance the tower levels of the atmosphere. Second is the lifting action. The lifting action. Some mechanism must lift the air so that the moisture can condense and release latent heat. So useless gihapon walay formation of clouds if walay kanang lifting action, or walay kanang this evaporation process. So next is instability. The portion of the atmosphere through which the cloud grows must be unstable. So siya ang three ingredients or 3 recipe of our thunderstorm: moisture, lifting action, instability. MLI. So next. And also there are stages of thunderstorms. So naay kanang stages. Murag tao pud ba kung sukad pagkabata niya, 0-month-old hangtod sa pagkapatay. Everything on earth has evolution and devolution. The thunderstorm has 3 distinct stages. First is the cumulus stage, the formation of fluffy clouds, which I did mention earlier. Next is the mature stage, severe rain and thunder. Next is the dissipating stage, fading stages of thunderstorms. So naay 3 distinct stages ang thunderstorm: cumulus stage, mature stage, and dissipating stage. So ato na siya i-talk each one of them and dig deeper kung unsay naa nga stage. So dito sa first stage, aritas cumulus stage. So cumulus clouds that exhibit the vertical development necessary for thunderstorm formation are called cumulus congentus or towering cumulus. So mga to siya kung giingon guys, like magkadaghan og kanang moisture nga ni saka ni build up adto sa atmosphere, magkataas pud ang magka-tower ang formation sa clouds, and then it will grow up to 10 miles or 13 kilometers. So mao nang kasagaran makita ninyo nga mura siya kanang softball cotton gusto ninyong kuhaon. So mao nang kanang ang outcome nga mahitabo sa pag-evaporate sa moisture gikan sa surface sa earth. Next is the main feature of the cumulus stage is the updraft within the cloud. As the updraft continues the updraft continues upward, the storm grows horizontally and vertically. So na gitawag og updraft. Asa ning updraft? Ang updraft is kanang ang simply ang kato kung giingon ganiha, like ang warm air ang warm air that causes the water to evaporate and then it will form clouds at the what do you call this, at the specific layer of the atmosphere is what we called updraft. Mga siya warm air na siya. Dinisaka din form of clouds, updraft. Up. So the updraft may extend from close to the Earth's surface to the several thousand feet above the cloud top. So mga siyang birth of the thunderstorm. Diba? Nagsugod sa kuan sa warm air and then kuha siya sa water vapor, dinisaka. Next is the updraft. As the updraft continues, the cumulus cloud becomes a cumulonimbus clouds. The clouds droplets increase in sizes. So mao siya magkadaghan og kanang transport the water vapor pa doon sa atmosphere is magka-darker ang clouds or mahimo siyang cumulonimbus. So meaning ana daghan na hold up na water vapor dito sa atmosphere and makadagat siya, magkabugat siya, and then magkadako siya. Then increase in size, yes. So, mga siyang porma sa towering cumulus stage. Mga ito siya, nisaka siya, warm air, and then that. Next stage is, mabaday. Mani siya. The thunderstorm, as the thunderstorm grows. As the cloud droplets grow into raindrops, they become too heavy for the updraft to hold them. Rain begins falling out of the cloud. The storm enters what's known as the mature stage. So manata sa towering cumulus stage. Next phase is the mature stage. Nagka-mature siya. Sana all magka-mature. So the towering cumulus cloud has grown into a full-blown thunderstorm and has become a cumulonimbus clouds. So mga to, ready na kayo na siyang ipabundak. And then, dagan na siya kanang accumulate ng mga water vapor at taas. Then the top of the storm may penetrate so high into the upper atmosphere that the top may be blown away by the jet stream. This top is called the anvil top because of this anvil-like shape. So mga to siya. Anvil. Mura siya anvil ba? Awas sa pinakataas. Kung mo ng anvil, ka na mura bugat nga ka ng skaran itom na siya. Makita mo na sa mga Tom and Jerry na mga shows. Hala siya. Mo extend pa dyan siya pataas. Mo penetrate pa na. So rain causes more updraft. As the raindrops begin falling through the cloud, they drag the surrounding air down with them. This produces a downdraft of the thunderstorm cloud, which serves to destroy the updraft that created the cloud in the first place. The speed of the downdraft can reach up to 2,500 feet per minute or higher. So, ito siya. There is a mature stage, the second phase. At the bottom of the cumulonimbus cloud, the air is being forced down by the downdraft caused by the falling rain. As the air leaves the bottom of the cloud, it begins to fan out as it encounters the surface. The spreading out of air causes strong and gusty surface winds capable of doing serious damage. This outward motion of the downdraft causes gust fronts to form and move away from the main thunderstorm column. In the mature stage, nearly equal updrafts and downdrafts exist side by side in the cumulonimbus clouds. So there is a mature stage. Dire na mahitabo ang downdraft. So so simple as that. Downdraft is the opposite of updraft. Diba updraft is kanang nisaka ang katong mga water vapor sa kuan. Sino balik-balik ani sa atmosphere. Then a downdraft is the cool air from the highest layers of the atmosphere will push the clouds nga naay mga water vapor and then it will cause precipitation. So mao ta kung giingon ganiya sa convection currents. Musaka ang warm air and then the cool air from the highest layers of the atmosphere, it will push and will penetrate to the clouds, causing the rain to fall into the earth's surface, and that how the thunderstorms see. That's how the thunderstorms occur as we see. So siya. Then it will cause as the downdraft happens, the gust of winds is mukha siya of clouds and it will cause heavy damage or more casualties sa Earth's surface. So, mga na siya naitabo. So, cumulus stage is ang updraft na itabo. Mature stage ang updraft and then the downdraft. Downdraft, more downdraft. So, mo ni siya. Dara ang anvil. So, nisa kang warm air. And then the cool air pushes. And then the cold air from the highest layer of the atmosphere, it will push downward to the clouds, and then it will form thunderstorm with rain showers, the lightning, the gust of winds, the thunder. So thunder. So sa mature stage sa diri sa, di ba, I mentioned nga na ay kuan happening sa thunder. So unsa ginaan ng thunder? So thunder is kanang sa clouds, sa formation of clouds is there's an excess of this, what you call this, the excess of charges, the positive and negative. Yes, the positive and negative. Then because of the transference of electron, dapat na jay kanang what you call this, the transference of electron mao na mo gawas siya in the form of lightning. So nang gipagawas ana is mga electrons, then there is sa Earth's surface kasigaran is mga positive charges. Mao na kasigaran mo conduct dayon siya, maigo dayon ang land, ang mga buildings, and then there is because of the transference of electrons, there is a breaking of sound barrier, and that's how thunder phenomena occur. So manay nanay magtingog. So because of the transference of electrons gikan sa clouds or sa thunderstorms to the sa Earth's surface. So manay mga dugdog ni mo mahitabo. Pero mo na dyan ang lightning and then the thunder. So naay transference of electrons mo na siya. And then the last stage is dissipating thunderstorm. As the mature stage of the thunderstorm progresses, the downdrafts continue to develop and the updrafts are weakened. So, kung sa cumulus stage is the birth of a thunderstorm, there is a dissipating stage is siya kanang murag padung na siya mo weak or padung na siya ka fade or mamatay or ma-disappear. So ang updrafts are mo weak siya, and then the downdrafts continue gyapon siya mo develop. The supply of warm, moist air runs out because the cool downdrafts cool the area from which the storm draws energy. So, however, the downdrafts spell the death of the thunderstorm. Without the updrafts to drive the cloud formation, the rain gradually subsides and the storm loses its power. So, wala na updraft motion is wala na say downdraft motion nga mahitabo kay wala na may mo sustain or mo provide sa energy nga nakuan or sa power nga nakuha gikan sa Earth's surface. So magkaanam na siya ka fade or mahinay ang rainstorm, and then wala na yung mga kulog-kulog, mga kidlat-kidlat. And then the storm may still be producing the characteristic thunderstorm weather, hail, heavy rains, and then tornadoes. Mga siyang dissipating stage. Mga siya, nagkawawa na siya. No? There is sa mga lower layers. And then, mauna na akong topic. And that wraps up my topic about thunderstorm. How thunderstorms form and the stages of thunderstorm. So, then the next reporter, she will talk about the types of thunderstorms, and this is the most important, how or the tips to avoid lightning strike. So siya maghatag siyang tips. So paminaw gid mo. I think that would be all, and have a good day.